Humans need electricity in various lives, starting from lighting, entertainment facilities, energy sources of all kinds of household electronic goods, to heat generators in the home industry. In addition, electricity can also be used as a generator of motion. Electricity has very diverse functions for various fields, and human existence is very dependent on electricity. In generating electricity, it is necessary to develop a qualified infrastructure. One of the main components used in the construction of the infrastructure is an electric generator. Generator is a device used to convert mechanical energy into electrical energy. One type of generator that is commonly used is a magnetic generator, or commonly known as a permanent magnet generator. Technician using CNC machine. The term CNC is an abbreviation of Computer Numerical Control, an Indonesian numerical control machine, and the definition of CNC is that this machine is a machine used in manufacturing processes that usually use computerized controls and equipment. The most dominant advantage is the speed in the production process, so it is suitable for mass production. The first CNC machines were made in the 1940s and 1950s, by modifying ordinary machine tools. At first these machines cost money to manufacture complex workpieces due to the manufacture and large volume of control units. Few companies were willing to invest in developing this technology. 1975 was the year when this automatic control machine began to develop rapidly because there was already a microprocessor so that the volume control could be reduced and simplified. Currently, machines are widely used in all fields, such as in education and research, and of course international industries. Interested in this machine? Check the video description. Definition of magnet generator. A magnet generator is a generator produced from a permanent magnet that is not a coil. Thus, this generator produces magnetic flux energy with the permanent magnetic field. Magnet generator parts and how it works. There are several parts of a magnetic generator. The first is the rotor, which is a permanent magnet as a generator of the magnetic field. The magnets are arranged on a pair of media with a disc-like shape that flank the stator so that it creates a flux that surrounds the stator coils. This magnetic field does not need a DC excitation current. The second part is the stator, which is a rotating coil of wire. This winding acts as a receiver of the magnetic field generated by the rotor so that the ends of the stator will generate electricity. The number of stator windings can affect the quality of the voltage generated by the generator. Types of permanent magnet generators. There are two types of permanent magnet generators which are distinguished according to the flux flow, namely axial flux permanent magnet and radial flux permanent magnet. Axial flux generator permanent magnet, or commonly abbreviated as AFPMG, is a generator with a flux field that has a direction parallel to the axis of rotation. Flux energy is generated from the attractive force between a permanent magnet with two different poles. In axial flux permanent magnet, the stator is made of non-magnetic material so that it does not affect the running of the magnetic rotor. This generator has the advantage of other model generators, namely that it can be easily adapted to air conditions because it is designed with a high power ratio with minimum core material. This axial flux permanent magnet can also reduce additional topology and reduce noise and vibration levels due to the flux airflow direction that varies. Meanwhile, in the radial flux permanent magnet, this generator has a flux direction that is in the direction of the rotation of the rotor due to the magnetic rotor arranged in a circle covering the outside. This generator is also accompanied by an inner core that will be connected to the center of the rotor. The advantages of radial flux permanent magnets are easy to install and have a structure similar to DC or AC motors that are often encountered in everyday use. Magnet generator function. Magnetic generators have very diverse functions in life, ranging from energy utilization such as solar thermal energy, wind turbines that utilize wind power. Magnetic generators are also used in various industries such as generators in electric turbines, changing the power output of steam turbine engines, converting energy in gas turbines, generating electricity that is useful for the grid, to reciprocating engines. However, its use requires a generator that is in accordance with the electrical rotation required by the tool. Thus, Each generator must be developed to produce the required voltage and frequency.
The need for electrical energy in Indonesia and throughout the world is increasing. While most of the energy sources for power generation still use fossil energy such as oil, natural gas and coal. Fossil energy has a high level of pollution, which is the cause of global warming. Besides that, fossil energy itself is decreasing day by day. It is necessary to replace fossil energy that is environmentally friendly, namely renewable energy. For this reason, smart solutions are needed to overcome these problems. Micro hydro power plant, PLTMH, unlike fossil power plants such as PLTU, steam power plant, whose turbines and generators rotate rapidly at 3000 revolutions per minute to produce electrical energy, the turbines in MHP have a low rotational speed of about 200 revolutions per minute, and have low rotating torque or have no cogging effect. Torque. Therefore, a neodymium, and Feb, coreless neodymium, and Feb, permanent magnet axial flux generator was made, which is specially designed for low speeds of 200 revolutions per minute and has no cogging torque effect or low rotational torque. And it is hoped that the design of this generator can be used according to the needs of the MHP. The results obtained, the generator can produce a voltage at a rotational speed of 200 RPM and a frequency of 50 Hz as 100 volts. The voltage and frequency can increase according to the rotational speed of the generator. The power generated by the generator at a rotational speed of 400 RPM as 200 volts.